congratulations. It is great that you are one of the winners of the flagship project. Could you give me a little bit more thought? What is your invention going to change in my life 20 years from now?
Oh, thank you very much. It's a great opportunity for us to be one of the first flagships of European research. Graphene is a multipotent material. It has a lot of different opportunities. So your question is actually rather difficult. I would like to quote Herbert Kroes, who is one of the Nobel laureates in physics, who said that the main application of any sufficiently new technology is something that is only made possible by it. So since graphene is a new technology, 20 years is a difficult horizon for us to predict, but we can see great applications in flexible electronics. Electronic paper is one of the first things coming out. New kinds of composite materials, ubiquitous electronics. You can have electronics in your clothing, for instance, or integrated in wallpaper or in many other ways. But because the technology has so many different possibilities, it is quite difficult to pinpoint exact application areas in 20 years' time.
I got a story that Scotch tape is quite close to the whole invention. Could you explain a little bit more, and how much Scotch tape did you use in your experiment?
Scotch tape is indeed the first method how graphene was made in 2004 in Manchester, where essentially all you need is a pencil and a Scotch tape. And in one of the flagship pilot events, I think in Budapest, we actually had a setup where visitors could make their own graphene, and many did. Many Commission representatives did. I'm not sure if you did. Of course, Scotch tape method is something that works very nicely in the laboratory, but it's not going to be the basis of an industry. So one of the things that we are developing is more large-scale production techniques that allow graphene to be produced in right quantities, in right qualities, and at the right price.
Is this an example in which you can have the understanding that our society will change completely? For if it is going through, it is not that costly. It is making a lot of difference, talking about aspects that you are mentioning upon. What type of differences in a daily life on a short term could we be aware of? And is there a lot of employment, a lot of jobs connected with this new development?
Yeah. Graphene is a ubiquitous technology. So in the future, you can imagine graphene being produced roughly the same way as newsprint is produced today, with very large machines that produce 7-meter wide material at 200 kilometers an hour. And it will certainly have major impacts. Think, for instance, about lightweight composite materials, because graphene is 100 to 300 times stronger than the strongest steel. So in airplanes, in cars, you can reduce the weight, you can improve energy efficiency, new kinds of medical implants. There are plans for instance, retina implants. There are techniques now that are being developed to use graphene membranes to desalinate seawater to make it potable. So it's a technology that has very wide application area. So it will certainly penetrate the life of Europeans on many levels. And because of these great opportunities, we see that there is also great potential for new products, new investment opportunities, new job opportunities, and increased economic growth in Europe.
Professor, no scarcity of resources. I'm wondering what your thought is. And does this mean that steel industry will be gone after a couple of decades when this is all normal stuff, so to say?
To answer your first question, there is no scarcity of materials because you can use just about any carbon-containing material to make graphene. I've heard reports where people have started from chocolate to make graphene. I personally think there are better uses for chocolate. We are not out to put an end to the steel industry, and we are not out to put an end to the silicon industry. We don't want to replace steel or silicon. We want to do things that cannot be done with the existing materials platforms.
Well, if you are explaining that it is lighter, that it is perhaps less costly compared to other raw materials that are needed for production of certain products, then I can imagine that this will be a changing not only of the mindset, but a changing of our industrial policy and talking about all the opportunities that are at stake.
Yeah. Andre Geim, who's one of the people who received the Nobel Prize for groundbreaking experiments with graphene, sometimes compares graphene to plastics. The same kind of impact as plastics had in our lives in the 20th century. That's something that we can compare graphene to in the 21st century.
Now I'm attracted to the question, what are the consequences for our environment?
Graphene is carbon, so as such, the environmental consequences are going to be rather minor. Of course, you can see that if we take graphene and we burn it, we'll create some carbon dioxide. But by comparison, that is a minuscule amount because we are only talking about a material that is a single atomic layer thick. So the environmental issues and health issues are something that are an integral part of the flagship. We will invest significant funds to explore them, but presently we do not see that there are any worrying issues there.
Professor, now graphene is still in the labs. Can you, with the award you got, the money you got, can you just get the graphene out of the labs into industrial processes?
You are pretty much saying the final line of my presentation in the press conference in a few minutes, where we want to take graphene from the European academic laboratories to the European society. That's what we want to do, have academics and industry work together and to make sure that the fruits of this European research can be harvested in Europe.
Thank you so much. We are interested in the graphene valley in Europe and perhaps their valleys. Thank you.
Thank you very much.